Welcome to this tutorial on PowerShell Workflows. In this video, we'll explore how workflows enable you to automate long-running tasks and manage complex operations across multiple systems. Workflows are a powerful feature in PowerShell that go beyond simple scripts, providing built-in capabilities for persistence, parallel execution, and fault tolerance. Whether you're managing server infrastructure, automating deployment processes, or coordinating tasks across multiple machines, workflows offer a robust solution for enterprise-level automation challenges. So what exactly are PowerShell workflows? A workflow is a special type of PowerShell command specifically designed for handling long-running, distributed, and parallel tasks. Unlike regular PowerShell scripts, workflows are built on top of the Windows Workflow Foundation, which is a Microsoft technology that provides a robust framework for task execution and recovery. This foundation gives workflows unique capabilities that regular scripts simply don't have, making them ideal for enterprise automation scenarios where reliability and resilience are critical. There are 4 key benefits that make workflows incredibly valuable. First is persistence, which means your workflow can resume execution after interruptions or even system reboots. Second is parallel execution, allowing you to run multiple tasks simultaneously across different systems, dramatically reducing overall execution time. Third is fault tolerance, with automatic retry mechanisms and built-in error handling that make your automation more reliable. And fourth is remote orchestration, giving you the ability to coordinate complex tasks across multiple machines from a single workflow. These features combined make workflows perfect for scenarios like patch management, system provisioning, or any task that needs to run across many servers. Let's look at the basic syntax for creating a workflow. You start with the keyword workflow, followed by the name you want to give your workflow, in this case, test-workflow. Then you open curly braces, and inside those braces, you place your workflow activities. In this simple example, we're running 2 commands: get-service to retrieve information about the spooler service, and get-process to get information about PowerShell processes. Notice that the structure looks similar to a PowerShell function, but the workflow keyword tells PowerShell to treat this differently, enabling all those special workflow capabilities we discussed earlier. One of the most powerful features of workflows is the ability to run commands in parallel. By using the parallel block, you can execute multiple commands simultaneously rather than one after another. In this example, we have 3 commands inside the parallel block: get-service, get-process, and get-event-log to retrieve the newest 100 entries from the system log. Instead of running these sequentially, which might take several seconds each, the workflow executes all 3 at the same time. This can dramatically reduce the total execution time, especially when you're gathering information from multiple sources or performing operations that don't depend on each other. While parallel execution is powerful, sometimes you need strict control over the order of operations. That's where the sequence block comes in. This block ensures that commands execute one after another in the exact order you specify. This is particularly important when later commands depend on the results of earlier ones. In this example, we first get all services and store them in a variable called $services, then we get all processes and store them in $processes, and finally, we output the services. Each step must complete before the next one begins. This is essential for workflows where the output of one command becomes the input for the next. When you need to perform the same operation across multiple computers or items, the ForEach-Parallel loop is incredibly efficient. In this example, we have a list of 3 servers: Server 1, Server 2, and Server 3. Using ForEach-Parallel, the workflow processes all 3 computers simultaneously rather than one at a time. For each computer in the list, it runs get-service with the computer name parameter. So instead of querying Server 1, waiting for it to complete, then querying Server 2, and so on, all 3 servers are queried at the same time. This can reduce execution time from minutes to seconds when working with large numbers of systems. Let's recap the key concepts from this introduction to PowerShell workflows. First, workflows are specifically designed for long-running, distributed automation tasks that need reliability and resilience. Second, they provide built-in parallel and sequential execution patterns, giving you fine-grained control over how your tasks run. Third, workflows offer persistence and fault tolerance, meaning they can survive interruptions and handle errors automatically. And finally, they're ideal for orchestrating complex scenarios across multiple systems, making them perfect for enterprise environments. As you continue learning about PowerShell workflows, you'll discover even more advanced features like checkpoints, suspend and resume capabilities, and integration with PowerShell remoting. Thank you for watching this introduction to PowerShell workflows.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.